Only 15 there, yet many have to come. Yesterday we learned what is relation and how to find out domain of a relation, and which is called codomain, and even we learned range also, right? And we learned yesterday that how we can represent the relation similarly how we did in sets. We can represent relation in three ways, right? Ray diagram, yes. Then rule method, roster method. Rule method means set builder method. Roster means what? Tabular method. Okay. Yeah, in three ways we can represent the relation. Now let us see a little more about what the relation only with some other examples. Okay, take one example now. Okay, so I'm going to give a diagram here, right? See the diagram, right? There is a set named as P. There is one more set named as Q, having the elements 5, 3, 2, 1, -2, -3, -5. Okay, right. Yes. And 9 is mapping with what? +3 and -3. Right. Similarly, 4 is mapping with what? +2, -2. 4 is mapping with what? +2 and -2. Right? And 25 is mapping with what? +5 and -5. 25 is mapping with what? +5 and -5. So all you are able to see the diagram. The question is what now? Write this relation in set builder form. First one, write this in what? Set builder form. Second question is what now? Write it in roster also. Roster form also. Right? I think question over now. And even write its domain and range. Third one, domain and range. Okay. Let us find these three by using this diagram. Right? See, set builder form means, say, the relation, the set of all x, y, such that. Just see the picture now. 9 is related to what? -3 plus 3. It means what? +3, -3 are the root values of what? 9. Or your x is the 9 here. Okay, your x is the 9. Then what could be y? Y is what? Plus 3 and minus 3. Then what relation you can make with 9 by these two, 3 and minus 3? So 9 is the square of what? Plus 3 and minus 3. Correct, no? Yes. Therefore, I will write what? The order pair xy, x is square of y such that x belongs to the set P and y belongs to set Q. What I written that is what? Set feeder form. I done with what? Set feeder. Second question. In roster form, roster means you have to list. Okay, let us list what are those all. Okay, what is x, what is y. If I take x as 9 now, y must be minus 3 or y must be plus 3. Correct now? If I take 4 now, then you tell that 4 is the square answer of what? Minus 2, or is the squared answer of what? Plus 2 also. As per the relation. If you take 25 now, 25 is also what? The square of minus 5, or it's the square of what? Plus 5, right? See over. How many are there? 1, 2, 3, 4, 5, 6. 6 order pairs are there in what? Roster form, means tabular or listing method. But again, third one, they're asking domain and range. They're asking what? Domain and range. Okay. Domain means input value. What you input now, the left hand side, these values you are inputting. X values are nothing but input, that we call domain. See, what are those domain? Nothing but 9, 4, 25. All these are domain elements. The set domain I had now. Domain and range they're asking. Range means the answer. Range means the answer. Check it now. Range minus 3 plus 3, right now? Again minus 2 plus 2. Again minus 5 plus 5. All these are what? Range. In this, one is not mapped. In the set code domain, one is not mapped, right? So I can tell range here purely subset of what? Q, right? No? Not it is equal because one is left. So what it is subset? If it is one is also mapped, no, I would have written what? Subset or equivalent set of what? Your set Q. It is set Q, okay? Set Q. That we call codomain. Nothing. What do you call that? Codomain set. Right? Okay. Good. Most of the students are writing the answer. Good. No problem. Correct. Then yesterday, while solving a problem, I directly went to what? Number of relations. Right? That I will give now the note. Okay? Note. Take the note. Note. If n of A is equal to say P and n of B is equal to say Q, right? Then n of A cross B will be equal to what? P into Q, right? Or you can write directly PQ. This is number of elements in the Cartesian product. And the number of relations is nothing but 2 to the power of PQ. This you should remember. Number of relations will be always equal to what? 2 to the power of PQ. Okay. Yes, correct.
We'll see the next part of this.
Let us solve one more example, whether you are able to find out the total number of relations in this problem. Let me take one more example. Let there is a set A having the elements 1, 2, and another set B having the elements 3, 4. Right? Find the number of relations from A to B. Find number of relations from A to B. Then you make first n of A cross B is equal to how much? That is, you tell that n of A into n of B. Nothing but what it is. Here A having got 2 elements, B has having also totally 4. Then number of relations is equal to 2 to the power of 4. Nothing but 2, 4 times you should write right now. What is that? 16 what? Relations. 16 relations. Right. Number of relations. How many are there? 16. Okay. Let us see directly the exercise. This one you should remember one thing. Why? Because in exam we will confuse you this question. Remember, something will give you remember. Remember. If somebody is asked a relation on a relation on A is nothing but the relation is the relation from set A to set A itself. Right now, so they will not tell from A to A. They will simply tell define a relation on set A. If they ask define a relation on A, then you should think that it is between A and A only, right? Okay. We'll begin directly the next exercise. Okay. Let's see. Let us finish all the problems now. Exercise 2.3 or 2.2. Sorry. 2. There is a set they have given. Number 1, set A is having some elements 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Define a relation from A to A by R. They're asking define a relation on A by relation they have given. Relation is nothing but the set of all order pair xy such that 3x minus y is equal to 0, where xy belongs to set A, where xy belongs to set A. They're asking write down its domain, codomain, and range. Right. Its domain, codomain, and even range also. You have to find all these. Okay. Let us find. Okay. Now, if you take a and a only, but the condition that 3 times of x minus y must be equal to 0. Come on. 3 times of 1 is 3. 3 minus 3 is 0. I know. Again, 3 times of 2, 8. 8 minus 8 is 0. I know. Again, 3 times of 3 is 9. 9 minus 9 is 0. 3 times of 4. 4 4s are 16. 4, 64. Not possible, right? No? Why? Because 64 is not there in this. Let us see with ray diagram, okay? I will take what? 1, 2, 3, 4, so on, up to what? 14. Okay. Why? Because between set A, only set A they are making. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on, 14 I take. Okay. Now they are asking 3 times of x. They'll write here x. How many times? 3 times. Understanding? Is it minus y they're telling, right? Must be equal to 0. Okay, let us make 3 sum. 3 times of what? X. 3 times of 1, nothing but it is 3. Then if you put 1 now, you'll get what here? 3. Correct? If you put 2 now, here you'll get what? 8. Right now? X as 2, you'll get what? 3 into, sorry, 6 it is, sorry. 3 2s are 6, sorry. Not squaring, not taking power, you have to find, right. It is 6, right? Then 3 times of 3, it is 9. 3 times of 3 is what? 9. If you put 3, you'll get what? Answer as 9, right? Excuse me. Then if you put 4 now, 4, 2 times, 3 times 4, 3 4s are 12. Possible, right? No? I can write 12 here. 3 4s are 12. Right? When I will put 4, no, 4 3s are 12. Possible, right? Again, see, if I put 5 now, 5 3s are 15. Not possible. 15 is not belongs to set A. It is not there at all. Up to 14 only they have given. Even you can put what? So many, but you can't put. Why? Because they are asking from A to A. Your codomain set is what? A only. From A to A only, but in this A, 15 is not there. Of course, we can get putting any number, some number, but that number must be in the given set. It is not there. So we'll stop. Then they're asking, write relation from this. Let us do the relation. Already they have given in rule method. They have given a rule method. Right? Now we'll write in roster method. Relation is equal to, come on, 1 3, am I correct? 2 6, right? Again 3 9, yes. Again 4 12. How many got this are correct? Right. One have given answer. Perfect. What x you'll put now, that is called domain. Now domain itself will understand. Domain. The left elements are nothing but domain. 1 2 3 4. 1 2 3 4. Input are called domain. ಏನು ಹಾಕಿದಿರಿ ನೀವು ಎಕ್ಸ್ ಬೆಲೆ, ಅವಾಗ ಹಾಕಿರೋ ಎಕ್ಸ್ ಬೆಲೆಗೆ ನಾವು ಡೊಮೈನ್ ಅಂತ ಕರಿತೀವಿ. ಆಯ್ತಾ? ಇನ್ನು ಔಟ್ಪುಟ್ ಏನು ಆನ್ಸರ್ ಬಂದಿದೆ ಅವುಗಳಿಗೆ ರೇಂಜ್ ಅಂತ ಕರಿತೀವಿ. ರೇಂಜ್ ಹುಡುಕಿ 3 6 9 12. 3 6 9, 12. Range. They asked what? Domain, codomain should write now. Let us write code. Codomain, the set A itself a codomain. Why? Because you are making relation on the same set. Therefore, codomain is equal to set A only. Nothing but what you know? 1, 2, so on up to 14. Very easy problem. I hope all you understood. Say yes or no. Understood? Good. We'll see the next problem. Let me erase it. Domain, codomain, range, everything is in your mind now. Understood? Okay, let us erase it. Second problem. They're asking define a relation R on the set N, right? Of natural numbers, are they given? Define relation on natural number set, right now? N means natural number set. They have given what should be relation. Relation they have given that the relation is nothing but set of all xy, order pair xy, such that y must be equal to x plus 5. Right? X is a natural number. Oh, again the condition continued. X belongs to natural number set. Less than 4 must be less than, that is, x must be less than 4, where xy must belongs to natural number. Xy both belongs to natural number set. Means again you are doing only one set. The same set you are taking n and n. Codomain as well as what? Domain also. Depict this relationship using roster form. Write down the domain and range. They are asking to what? Roster form. Okay. Let us see how we can. For easy purpose, we can draw a diagram also, right? Natural number means 1, 2, 3, so on. Then 1 plus 5 is equal to 6. 2 plus 5 is equal to 7. 3 plus 5 is equal to 8. 4 plus 5. You can't put 4. Why? Because the condition they given, x must be less than 4. Right? Let us see the solution. Okay, we'll take this very easy method to make you understand. I'll put x here and I will get y also. Y means what? Y is equal to x plus 5 it is, I know. Then if I put x as 1, I can put only x 1, 2, 3 only. Not 4. Reason given, x must be less than 4. They only given. So if I put 1 now, 1 plus 5, it is 6. 2 plus 5 is 7. 3 plus 5 is 8. Finished. Right? Then relation in roster form, that I will write 1, 6, 2, 7, 3, 8. Any possibles are there? Check it now. Any possibility? Other? No one listening, I think. No possibilities. Correct? Now, why? Because condition, you stopped up to what? 3 only. Less than strict inequality. Already you learned linear inequalities. Right now, sir already taught you. It is a strict inequality. Right now? Right. Okay. Then we'll stop here. How many order pairs? 1, 2, 3 only got. But the question is not stopped. They're asking, not only that, they're asking to write what? Domain and the range. Domain. Left elements are all what? Domain. Domain.
all left elements. Means input are called domain, right? No? You input x as 1, you input x as 2, you input x as 3. Not more than that, right? No? Range. So wherever you see 1, 2, 3, right side you see what? 6, 7, 8. Finished. Easy, right? Good. We'll go to the next problem, third one. There are two sets A, B. They're asking to define a relation from A to B such that the relation is a set of all x, y. The difference between x and y is must be odd, where x belongs to A and y belongs to B. Let's see the third one. Third problem. A 1 2 1 2 3 5. Set A having 1 2 3 5. Set B is what? 4 6 9. 4 6 9. Again, they're asking relation from A to B. They're asking the relation from A to B that they have given. Relation is equal to the set of all order pair x y such that the difference between x and y is odd. The difference between x and y is odd. They are not telling whether difference between from x to y or y to x, but if you take difference, there must be, it must be odd number. X belongs to A and y belongs to B. Okay. Write R in roster form. R in roster form. You should write. Okay. Nice. They are not asking any range, domain, codomain, anything, right? See. Let us take the easiest solution. Okay. They're asking the difference must be what? Odd. If I take A as 1, 2, 3, 5. Okay. A. And B as what? 4, 6, 9. If I take these two 1 and 4, whether between difference is what? 1, 4, if you take difference 3, 3 is odd number, then I can pass. 2, 4, not possible. Why? Because if you take difference between 2 and 4, now 2 is the difference, that is even number, not possible. 2, 6, not possible. But 1, 5, 1, 6 possible, 1 and 6. See, 1 and 6, if you take difference now 5, it is 5 is odd number. Again, 2, 9, yes, possible. 2 and 9, it's 7 is the difference, 7 is odd number. 3, 4, possible. 3, 4, possible because 1 is odd number. 5, 4, possible. 5, 4. Why? Because 5 and 4 difference is what? 1. 1 is odd number. 5, 6, possible. Difference is what? 1. 5, 9, not possible. Why? Because 5, 9, difference is 4. 4 is even number. 5, 4 already finished. Okay, now you got it. That I can give you the same. Relation is equal to, we can have 1 with 4, right? Odd difference comes now. 1 with what? 6 also. And 1 with 9 not possible because 1 and 9 difference, it is 8. 8 is even number, not possible, right? Okay, 1, 6 finished. Again, if you come to 2 now. 2, 4 not possible. But 2, 9 is possible, right? 2, 9 is 7, right? 3, yes. 3 with 4 we can take. 1 is difference, 1 is odd number. Again, 3 with 6 also we can take. 3 with 6 also we can take, right? Why? Because 3 minus 6 is 3 only. So 3 can be taken. 6, that difference is odd number. 5, 4 is possible, right? Again, 5, 6 is also possible. See how many you got now? 1, 2, 3, 4, 5, 6, 7. Whether you got 7? Yeah, number of order pairs are what? 7. Anything possible? See,
Any difference is what? Odd. See? Not possible. Good. Then they ask only write in roster form. Written the answer, right? Roster form only. Correct? The answer in roster form only. Okay? Yes. Okay. Copied on. Then shall I get to the next one now? Fourth problem. One more is waiting. Who is that? Yes. Fourth one, they have given a figure. In fourth, they have given a figure. 5, 6, 7 in set P. 5, 6, 7. Set Q 3, 4, 5. Right? Okay. And they made it directly 1 to 1, 1 on 1. Right? From P to Q. They went from P to Q. Show relationship between set P and Q. Write this relation. First one. They are asking write this relation in set builder form. In set builder form. Again, they are asking roster form also. They are asking roster form in roster form. Let me see what they're asking in. Asking domain and range. Domain, range. All these we have to find. Okay, let us find. See. Set builder form. First, see the picture. Okay. 5, 3. What relation is there? 6, 4. What is the relation there? Right now? 7 and 5. If you take difference now, the difference is even. I can make the relation like this. Difference is even. Then write set builder form. R is the collection of all order pairs of what? X5 such that difference between X and Y is even, and X belongs to set P, Y belongs to set Q, right? Right? Correct. X minus Y is equal to 2, right? Even you can write like that, right? And in roster form, what are those relations? Already diagram only given 5, 3, 5, 3, right? 6, 4, 7, 5, finished. Then they're asking domain. All first elements are what? Domain. All first elements are what? Domain. Nothing but input. 5 if you place now, you'll get 3, 6 if you place now, you'll get 4 answers. If you place 7, you'll get 5 answers. The domain, nothing but 5, 3, sorry, 6, and 7. These are the domain. Range, all the right elements of the order pair, 3, 4, 5. Here your domain, your range and codomain are equal, is equal to codomain also. Codomain set is P, that is set Q, right? We'll see the next problem. Fifth one. Set A having some elements 1, 2, 3, 4, 6. Fifth question. A is equal to 1, 2, 3, 4, 6. Right? R be the relation on A defined by R is a relation on A defined, they only defined as R is equal to, they're telling R is, they have not given R, but I'm only reading R is equal to the set of all order pair of A, B such that A, B belongs to set A only. B is exactly divisible by A. They're telling B is exactly divisible by A. This is the condition. Condition means relation. First one. Write R in roster, right now? Write relation in roster form. Second one, they're asking, find domain. Domain. Third one, find range also. Find the range also. Let us find. A is given already 1, 2, 3, 4, not 5, directly 6 they have given, right? And relation should define on set A only. Let us see the diagram. Set A having 1, 2, 3, 4, 6. Again, between set A only, you have to take 1, 2, 3, 4, 6. These all are A. They have given, instead of XY, they have given, these all are what? A. These all are what? B. Right? Then order pair AB is B is exactly divisible by A. See, if you take 1, whether this one divides 1, yes, divides. Right, then map it. Whether this 1 divides 2, yes, 1 divides exactly 2. 1 divides exactly 3. 1 4s are 4. 1 6 are 6. Possible. Right? Whether 2 divides 1, no. 2 divides 1, but it is not exactly. 2 divides 2 exactly. I will take different color. 2 divides 2 exactly. Whether 3 divides 1, 3 divides 2, no. But 3 divides 3 exactly. Whether 3 divides 4, no. But 3 divides 4, 6 exactly. Possible, right? Similarly, you think of 4. Whether 4 divides 1, 2, 3, no. 4 can divide what? 4 only. Right? 4 can divide 6? No. Similarly, 6 cannot divide 1, 2, 3, 4, but 6 can divide 6. 6 can divide. 6 can divide 6. Correct? Exactly, they're asking. 2 divides 4. Why is this? 2 divides 4. I have not given, no? Oh, yes, 2 divides 4. It's correct. 2 divides 4 also. 2 divides 4 also. Right? Any other missing? 1 divides all, right now? Then they're asking, write in roster. Start writing roster. If you take roster, form is 1 divides all. 1, 1, so on, 1, 6, right now? Correct now? Again 2 with 2 and 4. I'll write a different color for you there to make you understand. 2, 2, 2, 4, right now. Right. Again 3 divides 3 also and 6 also, right? 3 divides 3 also and 3 divides 6 also. 3 divides 6 also, right? Again 4 can divide only 4. 4 can divide only 4. 4. Oh God, not writing it is. Let me write with what? Black. 4 can divide 4 only, right? Again 4 never divides 6. 6 can divide 6 itself. No, none of them. Count total possibilities. 2 divides 6 are not done. Oh, right now 2 divides 6 again. I left it, right? 2 divides 6 also, right? I can make what here? 2 divides 6 also, correct? Correct, right? Come on, count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 are there, 12 not there. Oh, no, it's fine. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are what? 12. Perfect. Why? Because there is no 5. There is directly 6 is there, right? Then we can write n of r. N of r. How many? 12 ordered pairs. For your understanding, okay. Domain, very easy. All the first elements. 1 is a domain, 2 is a domain, almost all came. 3 is domain, 4, 6, all. Right? Again, range, all the answers. All are mapped only, nothing is left. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. All came range. Right? Everything is finished. Here domain is equal to range. Not only domain is equal to codomain also, again range also. See, both sides are same. Your domain is equal to range, your domain is equal to codomain set. Whole codomain set is also range now here, right? Right. We'll see the next one, 6th problem. What is 6th problem? Determine the domain and range of the relation R defined by, they have given a relation. The relation is given. What is that relation? Relation is the set of all order pair of x and x plus 5, right? Such that x belongs to one set. They have given set, that is what? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Means whole number set restricted to what? Up to 5 only, right? Yes. They're asking determine domain and range. Determine domain and range. Let us find domain and range. Okay, x plus 5 means the relation is on the same single set, right? Then I'll take what? This, let me call this as what? A, okay? I will call it A. Then A set having how many elements? 0, 1, 2, 3, 4, 5. Again A only. 0, 1, 2, 3, 4, 5. X belongs to 0, 1, 2, 3, 4, 5. If I put 0 now, 0 plus 5 is 5. If I put 1 now, 1 plus 5 is 6. Not possible at all. Right? I can put only 0. If I put 1 now, 1 plus 5 is 6. 6 is not there in this. Right? Therefore, domain and range they're asking. I'll write first relation. Relation is equal to only one order pair, 0 and 5. Right? Then what is the domain? Domain. Only one element, that is 0. Right? Again, range. Only one element, that is 5. Finished. Good. See, the ray diagram will help you like anything. It makes very clear understanding. We'll see the 7th one. Write the relation R. They have given relation. And 7th one, what they have given? See. Seventh problem. Write the relation R such that R is the set of all order pair of x cube such that x is a prime number. Here x is a prime number less than 10. Less than 10. They are not telling less than or equal to. They are openly told less than 10. Write this in roster form. In roster form. Let us write in this roster form. Okay. X cube. X is a prime number less than 10. Let me take first prime number list. Okay, less than 10. Solution. Set A having what? Prime number less than 10. Come on, what are those? 2, right? 3, right? 5, 7. Any other possible? 8, 9, not possible. Finished. The x cube they are asking. X cube. X is a prime number less than 10. Again, between x only x. How it is possible? 2 cube is 8. Possible? But 8 is not there in what the question? They asked the relation on the same set only, I think, right now. You can put x up to less than 10. Yes. You can put up what? You can put x less than up to 10, right? 8 is less than 10. Any other possible? X is a prime number less than 10. Means you can put all these prime number less than 10. They are not asking. Answer must be less than 10. See? We can put all these 2, 3, 5, 7. Possible? The input must be less than 10. Must be a prime number. Domain must be a prime number. And must be less than what? 10. Not possible. Why? Why it is not possible? See. What is there? They have asked determine the domain. Okay, question number 7 it is. Right, the relation R. Roster form, prime number must be less than 10. You have told 8 is less than 10. If you put out 3 cube, 9. 9 is also, hey, no, not it's 9. It's 27. No, not possible. It is not less than 10. Let us see. It is what? Exercise 2.2. 2.2. What could be? Our perception is correct or what? 2.2. Seventh one, right? Yes, we can put what? All those 2, 3, 5, 7. The restriction is for only domain. They are not restricting for what? Range. Right? Even in sixth problem, we done something wrong, I think. See sixth problem. X they are putting what? Restriction. They are not putting any restriction for x plus 5. Sixth also it is, we did something wrong, right? We'll begin from sixth. Even first I finished what? Seventh one. Again I'll go back to sixth one. Okay. Yes. Let us see what could be our answer. We done something in wrong in sixth also, right? Let's see. I will finish for seventh one now. Restriction only for input, that is domain. Domain must be less than 10. Here, domain, nothing but inputs less than 10 and must be a prime number. Must be a prime number. 2, 3, 5, 7, all we can put, right? Therefore, I will put what? X cube, right? See, I can put what? X as 2 also, X as 3 also, X as 5 also, X as 7 also, right? Then when you put 2 now, X cube is 8, 3, 27, 5, 125, 7, 49 into 7. 343 it is, right now? Right. 343. Then question is what? Only roster form you should write. Nothing else. Roster form, nothing but you write what? 2, 8, 3, 27, 5, 125. Right? Again now. 7, 3, 43. Right, finished. We have to do one more time the sixth problem. Sixth problem, we understood something different. Let's see, what is that? Sixth one. Sixth, one more time I'm doing now. Determine domain and range of the relation R. X plus 5, there they go. Sixth, they have given X plus 5. Such that X belongs to a set having the elements 0, 1, 2, 4, 5, 0, 1, 2, 3, 4, 5. Right. There is no restriction for what? The output means range might be anything, but they're asking domain must be only these elements, right? Solution. Okay, we'll see x plus 5, correct now? Start now. When you put what? X is equal to 0, 0 plus 5 is 5. 1 you put now, it's 6. 2 now, it becomes 7. 3 becomes 8. But 4 now, you'll get what? 4 plus 5, 9. You know, if you put what? 5 now, 5 plus 5 is 10. Right? Hoping you are understanding. There is no restriction for what? Range. There is restriction for domain only. Right? So then they again ask the question to write. See what they ask the question. Sixth one. They're asking you to write sixth. Domain and range you have to find in this domain and range. Domain means whatever you values you put no x, all are what? Domain. These are all what? Domain. Inputs. Whatever the output you got, no, all are what? Range. Now they ask domain and range.
I can write directly domain 0, 1, 2, 3, 4. The whole set only it is. Range is not like that. Range is 5, 6, 7, 8, 9, 10. This is what range. Understanding? Restriction is for only the X input. Input you have to put up to 5 only. But they are not restricting the output. Output might be anything. In the problem number 6 and problem number 7, we are noticing the same. Input, they have restricted. For output, there is no restriction. Whatever the answer, you take it as what? Output. Output means range. They never told that the range must be in the codomain like that. Simply they have given free for that, right? Yes. Restriction, you have to understand what conditions they have given in relation. Let's see the next one. 9th problem. No, it's 8th problem. 8th one. Whether you have got any other class, it is 3 to 4 now. Enough time is there, right? Let me finish these two, okay? I'll make finish. 8th one, A is having elements x, y, z, x, y, z. B having elements 2, only 1, 2. Find number of relations from A to B. Very easy, they are asking number of relations from A to B. I know n of A is equal to 3, n of B is equal to what? 2, n of A cross B is equal to how much? 3 into 2 is equal to 6, right? Therefore, 2 to the power of 6 is equal to how much? 32 into 2. How much? Is it 64? Right? 64 relations. Correct? Right. Then we'll go to the next last one. Let R be the relation on Z. Z means what? Integer set. By the R is given, 9th problem. Relation R is given that the set of all ordered pair AB belongs to integer set. A minus B is an integer. A minus B is an integer. Means A minus B is integer. Means Z only the. Find domain and range of R. They're asking find domain and range of A minus B. Okay, solution. AB belongs to what? Integer set only. We know that integer set means what? So on -2, -1, 0, 1, 2, 3, so on. Right now, all these. If you take 1 minus 1, 0, 0 is there in integer set. Right? For all A and B, A minus B, the answer is coming into the integer set only. Check it now. If you take any two numbers, say -2 and -1, -3. -3 is there in integer set. Right now? Then what the question they are asking now? They simply they are asking domain and range. Domain and range both are same. Whatever you put now, you can put all these. Whatever answer comes now, answer all these are present in the same. Therefore, I will tell your domain is also integer set. Your codomain or range is also integer set. Finished. From integer, whatever integer we put now, integer minus integer, again the answer is also an integer. Check it out, right? So this is the end of all this exercise. So we successfully finished the exercise. Now the time to say bye. See you. Any more doubts? Again, in the Monday we can what meet, right? Thank you. Thank you very much.
Have a great